Sean Finnegan, and you are listening to Restitutio, a podcast that seeks to recover authentic Christianity and live it out today. Now that we've considered a bunch of the options for interpreting creation in Genesis, we are moving to look at astronomy. In today's episode, Will Barlow moves into his home territory, physics. You'll learn about the weird nature of light, how particles do strange things at the quantum scale, and how the Big Bang model actually leads to belief in God. If you've ever been curious how to talk to science-minded friends and relatives about belief in God, today's episode should help. Here now is episode 464, part 6 of our Scripture and Science class, Physics and Astronomy, with Will Barlow.
Welcome back to Scripture and Science. We are in session 6. We're finally going to get into some scientific evidence. So we've spent the first 5 sessions looking at generally the topic of Scripture and Science, and then we spent 2 hours in Genesis 1 looking at various ways to interpret it. And so in this part of the class, we're going to spend about 8 sessions or so on the various branches of science. And in each session, we're going to look at either the current scientific evidence. We're going to look at how that current scientific evidence meshes with Genesis, either Genesis 1 or other accounts in Genesis. And then we'll look at interesting other aspects from that science. So we're going to buckle up because this session is about what I know the most about, which is physics and astronomy. So I'm very excited about it. I'm just going to give an overview of modern physics in this class. And again, if you want to Google this stuff and blow your own mind in your own time, I really encourage it. Some of the stuff is incredibly fascinating, and we're just going to be scratching the surface in this session on what is out there and available on some of this material. So please don't limit yourself to this session of this class. Go out if you're interested and look up YouTube videos on any of these subjects. They're fascinating things out there. We're going to talk about 4 specific things today. We're going to talk about light. We're going to talk about general relativity. We're going to talk a little bit about quantum mechanics, even though we're not going to use much of it in the class. I just think it's fun. And then we're going to talk about the Big Bang, which is where we're going to focus most of our attention, since this is where Scripture and science most collide, is on the idea of the Big Bang, or what is the origin of the universe. When I think about light, it's just, and we're going to look at some of the details of this, not enough. This is definitely one thing I would Google and have fun with, but perhaps it's the most interesting and necessary thing to support life. It's light. And light comes to us in Genesis 1:3. And it's just fascinating, the different qualities about light. Light comes in many forms. You know, we think of light as light from the sun, or things that we can see, different colors that we can see. But light comes in so many different forms, radiation, and it can act as a wave or particle, which is incredibly unique. It's a property of light that was discovered about 100 years ago by Einstein. It can work one way in one situation, one experiment, and work another way in a completely different experiment, and it's just fascinating to me. This is a physical description of light, and it communicates a lot of information about what light is. And again, you can use the term radiation. Radiation is light. Electromagnetic radiation, if you want to be even more specific. At the top, you have a depiction of a wave. And so you might hear the terms wavelength associated with light, with electromagnetic radiation. As you look at this chart, on the right-hand side is the longest wavelength. On the left-hand side is the shortest wavelength. And energy moves the opposite direction. So on the right side, you have very low energy light. On the left-hand side, you have high energy light. So for example, you think about visible light, you have the range there of colors that you can see. And then every other aspect of electromagnetic radiation we cannot see. So when you turn on your microwave, you can see the light bulb inside the microwave. That is not the microwaves themselves. The microwaves are a different wavelength. They're higher energy, and that's why you need the shielding around your microwave to protect you from the higher energy waves that come from microwaves and heat up your food in the microwave. Hopefully heat it up evenly, but as we know from experience, it never happens that way, does it? You might hear different terms: ultraviolet light, X-rays, gamma rays, infrared light, radio waves over there on the far right, low energy signals. I don't know if you've ever heard this. This is a bonus, but if you understand the difference between AM and FM radio, AM is longer waves, so it's lower energy. So FM is more powerful and can go further, but AM is actually better in like downtown areas where you have a lot of interference from high structures and stuff like that. So it's really interesting to think about like how these things work in relation to their physical properties. Anyway, that's a little bit about light. This is a depiction of a wave going through a slit, okay? And light can act like a wave. And so if you think about like a sound wave, or even a better visual description is like a water wave, okay? Light can act like a wave. What's fascinating and what Einstein discovered about 100 years ago is that light can also act like a particle. So what this is a depiction of is it's a depiction of particles going through two different slits. And so if you imagine like throwing basketballs, or I mean, you can use a more violent one like shooting bullets or something, I don't know. But if you're throwing basketballs through those two slits and you're marking, they're like, maybe they're paint covered basketballs or something, they're making an impression on the far wall behind the slits. You're not going to be able to throw a ball at such an angle to get through those slits to make a really wide dispersion pattern. It's just going to make an impression like the two slits on that far wall. And waves don't behave that way. When waves go through slits like this, they create interference patterns all over the place, and they reflect outwards and do all sorts of cool things. So it turns out that light can behave differently depending on the experiment that you run to look at light. It's fascinating, absolutely fascinating. Another aspect of light that I find really interesting is light seems to know the fastest path through a material. This becomes really important when we get to talking to later about general relativity and how the cosmos work in brief. But as light passes through glass, you can see it refracts. What's fascinating about that is it seems to know, although this seems crazy to say that it seems to know the fastest path. It bends at the exact angle it would need to take the shortest path through that glass and keep it going as fast as possible. So light slows down when it's in normal air, it goes into that glass, it refracts, and it takes a shorter path. And then when it comes back out, it refracts again. It's absolutely fascinating. The other thing that I'll mention about light is that the speed of light is a very well-known quantity and is considered by many physicists to be the speed limit of the universe. In other words, we don't think we could ever, even if we had like the most perfect engine and the most perfect fuel and everything, we could never get something with mass like a spaceship past the speed of light. Now there are sci-fi ways around that using wormholes and different things like that, okay? But I'm saying if you're moving like sort of linearly through space, the speed of light is considered the universal speed limit of the universe. Now this, and the reason why I mention this is because we talked about earlier that the young Earth creation way of handling this is to say the speed of light has changed over time. And I just want to point out that there's no scientific evidence for that. There's no reason to believe that that's true. Now that is an assumption made by science. I agree with that. And we can critique the assumptions of science all day long if we want to. I think that's valid. I think that's a valid approach. I'm just pointing out that we haven't been able to observe any changes in the speed of light over the last couple of 100 years. And that's an important thing for us to think about in light of these theories about the Bible. Transitioning to general relativity. I mentioned earlier in the class that general relativity is a theory of Einstein, and it has been verified enough that we actually have to use it in everyday items like GPS. So what we think about relativity, whether we think that it's perfect or whether we think that it may not be perfect 100%, whatever our view is, the point is that it has made practical differences in our world around us. And we use devices every day that incorporate this theory. And so, again, we may have some questions about the credibility of science on a large macro scale, but we can trust a lot of the conclusions that general relativity gives us. One of the cool ones, and the ones that's depicted in the picture here, is that everything that has mass, and I'm thinking mostly about bigger objects like planets and suns and stars and things like that, not people. I mean, I think technically we all do make a small impression in space-time, but I'm not mostly focusing on that. But here you have a depiction of like a star and how it bends the space-time around it, making an impression, okay? So if you think about stars having that kind of effect on space-time, that's how we understand planets going around. You remember those devices where you spin like a penny around like a big funnel, and it funnels and funnels and funnels and funnels and funnels? The bottom of the funnel, you can imagine, is the sun. And the Earth is like a penny that has no friction and that just goes around and around and around and around that device at a specific distance from the sun. And the other planets do similar things. And now, of course, the path of the Earth is not a perfect circle, and none of the other planets have a perfect orbit. They're slightly elliptical. But the point I'm trying to make is that's a visualization that can help you understand what this is saying. And it explains why we need massive objects like stars in the center of solar systems, why smaller objects like planets and comets and asteroids go around it. And they have a predetermined path based on how that space-time is bent. So this is a little bit about general relativity, just scratching the surface. Quantum mechanics. It's useful when talking about very, very tiny things. And here's a depiction of what you might have learned in chemistry class. You have the nucleus in the middle, which is positively charged. You have the electrons around the outside in different shells, okay? And this is depicting like a solar system view of electrons going around a nucleus. Quantum mechanics shows that this is wrong. Electrons, interestingly enough, are essentially popping in and out of existence in these different shell states. And there are probabilities of where they'll exist at any point in any given time. You can think of it like a positively charged star in the middle of the solar system, and then planets winking in and out of existence and asteroids winking out of existence in orbit around it. And we have an idea of where they might be, but we can never fully determine exactly where they are and where they're going at any given time. That's called the uncertainty principle. So this model that you might have been taught in chemistry class in high school is actually not true. Quantum mechanics shows it's way, way messier than that. Now here's a really strange implication of that, okay? So I have a table right here in front of me, and imagine that I reach my hand out to touch the table. What quantum mechanics tells us is on a microscopic level, what I feel as solid, what you feel as solid, is actually electrons in your hand repelling the electrons in the table. So if you could just think about it on a very small level, you've got these atoms, right? And you've got these electrons just bumping in and out of existence. That's what you feel as solid. It's wild, isn't it? It's crazy to think about it. The cool piece of this is, theoretically, your hand could pass through the table if you could line up the electrons in your hand with the electrons on the table. It's called quantum tunneling. And essentially, even though from a normal probability perspective, the probability is like essentially zero of you actually, even if you could determine to line them all up, that it could do it because there's such big forces involved at this low level, there actually is a theoretical possibility it could happen. If you want to Google quantum tunneling and spend an hour watching videos, I'm going to tell you it's time well spent. It's going to be fun. You're going to enjoy it. You're going to enjoy it. All right, that leads us to the Big Bang. And this is where I want to focus a lot of our time. So I think that the Big Bang is one of the most misconstrued things in modern Christianity. A lot of people view the Big Bang as an obstacle to Christianity because it's a scientific theory. It appears to explain the origin of the universe. And what I can tell you is that is a lie that has been taught by atheists in the last 50 years, essentially. That's in a nutshell what has happened in the last 50 years. The ground has been taken from theists for atheists to try to change the narrative on this. And so I want to explain a little bit of the backstory behind the Big Bang Theory, how we got here, and what different people's perceptions of the universe has been over time. And I think if we go through this just briefly, you'll see what I'm talking about. Now, Aristotle, for example, he was an ancient pagan. He believed in gods, plural. He believed that the universe always existed, called like a steady state universe. It always existed, and then the gods always operated inside of that universe. This view is attractive for modern atheists. Why is it attractive for modern atheists? Because it gets rid of the beginning of the universe. So you might be asking, well, like, what's the big deal about the beginning of the universe? Well, there's an ancient Christian tradition. We have one example, John Philoponus of Alexandria in the 4th century. He was a Christian philosopher who argued that the universe had a beginning. In the Middle Ages, when the Christian world sort of declined and people stopped taking notes and transcribing texts and things like that, Islamic philosophers preserved some of these arguments, and they renamed it the Kalam cosmological argument. Jewish scholars later brought this back to Europe at the end of the Middle Ages, and it got picked up by several notable Christian philosophers. This is the formulation of the Kalam cosmological argument, and it's incredibly powerful. And there's a modern philosopher named William Lane Craig who's done a lot of philosophical and textual work on this. It says, whatever begins to exist has a cause. So number one, if something begins to exist, it has to have a cause. Something had to bring it into existence, essentially. Number two, the universe had a beginning. That's premise number two. The universe had a beginning. Three, therefore the universe has a cause. Now, if the universe has a cause, what does that do for atheists? It says they're wrong. There must be something out there that caused the universe. Well, they would say that the universe just spontaneously happened. That's an atheistic perspective on this. So atheists are motivated to show that the universe did not have a beginning. So where does that bring us with the Big Bang? There was a scientist named Alexander Friedman in the 1920s who used Einstein's theory of general relativity to propose an expanding universe. A couple of years later, a Catholic priest and professional astronomer, Georges Lemaitre, proposed what would later be called the Big Bang Theory, using Einstein's relativity, general relativity, and the expansion model that was proposed by Friedman. And what's amazing is something that was developed almost 100 years ago by a Catholic priest who believed in God. It's still the same basic model that's being tested and tweaked today by scientists, and you are probably told that it eliminates the need for a God. Why were you told that when a Catholic priest was the one who developed it in the first place? Because the ground has shifted. And there's a reason why the ground shifted. We're going to talk about it. More evidence for the Big Bang. In 1929, Edwin Hubble discovered that faraway stars are redshifting in every direction. So what that means is the light is getting stretched. If the light is getting stretched, the wavelength's getting longer. They're turning redder and redder in every direction. It's not just happening in one direction. It's happening in every direction. Every star that we can see is redshifting. It only makes sense if the universe is expanding. So what scientists started doing is saying, well, if we extrapolate backwards, if it's expanding now, if we go backwards in time, what's it doing? It's getting smaller and smaller and smaller and smaller and smaller until you have a fixed point at the beginning of the universe, which they call the Big Bang. In modern times, we call it like a singularity event, is sometimes a scientific word that gets used for that. It's a singularity. It's a moment in time where something basically miraculous happens. They wouldn't use those words, though. The initial atheist response to the Big Bang was to propose alternate scientific theories. Now, this makes sense, right? I mean, if you're going to fight fire, you got to fight fire with fire. If you're going to fight science, you got to fight science with science. So they want to show that the expanding universe can be explained a different way. So they asked the question, what if the universe was expanding, but matter is continuously being created to keep the average density of the universe the same? So they imagine like an expanding universe that just had constant matter being poured into it, just being added to it. This is called the steady state hypothesis, and it was formulated, I believe, in the 40s or 50s. And this would allow for an infinitely old universe. Okay, this works scientifically. It would allow for an infinitely old universe that is expanding the way that we observe expansion happening. The problem with this, in the 1960s, two scientists by the name of Arno Penzias and Robert Wilson discovered the cosmic microwave background radiation. What is that? Well, basically, if you point a radio telescope at the space in between stars, you'll hear some interference. And what that demonstrates to us is that the universe was formerly more dense than it is now. This refuted the steady state hypothesis. So here we have atheists trying to come up with another scientific model to explain the expanding universe. And then within about a decade, evidence comes out and just torpedoes that theory. So they have to keep scrambling. They have to keep scrambling. They have to keep working. And we're going to see a little bit more of that development in more recent years. But one of the things that they did over time is they stole the ground from the Big Bang. They said the Big Bang can explain origins, and we don't need God. And what's interesting is that when people really look into it, like I'm showing you with this Kalam cosmological argument, if you really look into it, if you really dig deep into it, if the universe had a beginning, then that points directly at a creator. So, in basic terms, what does the Big Bang say? The Big Bang says that the universe began approximately 13.7 billion years ago, and that space and matter have been expanding and cooling since then. That's the basic understanding of what the Big Bang is. The Big Bang, like I said, was formulated by a Catholic priest and professional astronomer, someone who believed in God's existence. So the Big Bang, in and of itself, doesn't say that God does not exist. In fact, it could be a strong indicator that God does exist. Now, what is the current state of the Big Bang? What is the current understanding in science about it? Well, there are a couple of problems with the Big Bang. The first one is we don't have time machines. And maybe even theoretically, they won't ever exist. So, and I wouldn't recommend, even if you had a time machine, traveling back to the moment of the Big Bang. I think you might be in for more than what you expected. So we'll never be able to travel back in time to observe the beginning. That's the first problem. You're never going to be able to observe the singularity moment, the beginning of the universe. At least from a scientific perspective. Maybe God will show it to us someday. I would hope so. I'm hoping to see this. So what do physicists do? Physicists use high energy collisions to test hypotheses related to the Big Bang. Basically, they take protons and neutrons and all sorts of electrons, and they just like explode them. They get them spinning as fast as they possibly can and just bump them into each other and see what kind of explosions they can make, and see what kind of particles come out, see what kind of things that they can test. That's what they do. Because of our understanding of quantum mechanics currently, I just want to point out that there is a physical restriction on understanding the first moment of the Big Bang. So what I'm basically saying is there's a couple of tiny periods of time, very, very tiny, where science cannot explain anything about it because of what we believe about quantum mechanics right now. Starting from that moment onward, we have a decent explanation of the universe. But that first, microseconds, they cannot explain theoretically. Like, that is a scientific conclusion. We cannot know what happened in that first moment. As theists, can we offer a solution? Yeah. Now, that's a God of the gaps way of looking at it. And what I want to say is, we don't have to say that that is positive proof of God's existence. But what we can say is, that definitely points towards God. It's confirmation for our viewpoint. In addition to trying to shift the ground on the Big Bang itself, atheist scientists have come up with 4 different ways of providing alternatives to the Big Bang. The first one is oscillating universes. Universes that pop into existence, then they contract back. They explode, then they contract, then they explode and they contract. And imagine that this happens an infinite number of times until, voila, the Goldilocks universe exists, the one that we live in. So there could have been an infinite number of universes in past eons. That's how they get around what we're going to talk about next time about fine-tuning and how amazing the universe is, how it's amazing that we even have life and have water and have oxygen and all these things. The other option is, well, if you don't have multiple universes in time, maybe you have multiple universes in space, an infinite number of universes, especially if there's one like eternal mother universe that like generates these other universes. The other way they get around it is there's always a universe that existed, and it's the mother universe of our universe. And we're just like a little bubble universe, and there's tons of other universes all around. Okay. It's not a scientific theory. I'll just put it that way. Oh. That is a religion. That is a philosophy. That is not science. We cannot test whether there's bubble universes. We can't observe all of our own universe. But we'll get to that. They have what they call inflationary models. They also have Hawking's specific theory. I mentioned William Lane Craig earlier. In The Case for a Creator by Lee Strobel, William Lane Craig, who's a analytical philosopher and theologian, he has a PhD in philosophy, he has a doctor of theology. He's one of the greatest Christian apologists of the last 40 years. I think he does a lot of great work. I also disagree with him on a lot of things. Okay, so he's not perfect, but I think he says a lot of good things on this particular subject. He sat down with Lee Strobel in The Case for a Creator, and I wanted to point out a couple of his objections to each of these alternate Big Bang. Because again, atheists want to avoid the beginning of the universe, because the beginning of the universe points to a cause, and the cause points to God. So that's what they're trying to get rid of. So William Lane Craig refutes all these on scientific grounds. He doesn't say the Bible says one thing and the science says another. He doesn't play that game. He goes to the science and says the science isn't there. So what does he say about the oscillating model? He says it violates the laws of physics. A beginning is still inevitable according to general relativity. So it doesn't solve the problem they're trying to solve. He also says there's not enough density in the universe to contract the universe. In other words, we're expanding and now we're accelerating in our expansion. So we would never, in our current universe, ever expect for it to contract back in again, based on what we see right now. So if it's not in our universe, why could we imagine that prior universes had that ability? The universe is actually speeding up in its expansion, like I just mentioned. Some estimates, scientific estimates, say that only 100 universes could have existed before this one. So that doesn't resolve the problem. You still have the same problem. If you only have 100 prior universes, how come the one that we're in is just perfect? We're going to talk about the incredible probability that our universe exists the way that it does. And it's essentially, I'm going to tell you, the probability is 0. We should not exist. So if you only have 100 universes and you have a probability of 0 or almost vanishingly small, you multiply that vanishingly small probability times 100, the math just doesn't work out. If you can take a vanishingly small probability and multiply it by infinity, infinite number of past universes, infinite number of current universes, then you might get the math to work out a little bit better for you. You can say, well, there's a chance we exist. But that's the uphill battle that they're fighting. Here's the multiple universes, his critique of multiple universes. The multiple universes still can't explain the beginning of the model. They start with a quantum sea of energy. That's not nothing. That's something. It's still a sea of energy. So they can't even start from nothing. And then he says eventually, if you had all these bubble universes and they were just sort of floating around, eventually they'd start interacting with one another and colliding with one another, which means we would have experienced an annihilation before we lived. On inflationary models, William Lane Craig says that one particular cyclic model is inconsistent with the string theory that it's based on. So what he's saying is that they have these different models, and one of them that he points out says it's not even consistent with the physics they're using. So they're breaking their own rules, trying to shoehorn a theory in to get rid of the beginning of the universe. Another inflation model, it's called chaotic inflation, also does not resolve the problem of the beginning. You still end up with eventually a singularity at the beginning. In other words, it can only go back so far, and then you still end up with the beginning of the universe. It's the logical scientific conclusion for that theory. Hawking's theory is really interesting because what Hawking does is he takes his equations for how the universe works. And what he does is he inserts imaginary numbers into the equations. And so what that does is it gives you like it gives you a way to avoid the singularity at the beginning of the universe. Instead, you sort of have like a time loop at the beginning of the universe that could seem like it could be eternal. Like imagine you're walking around the earth and you're going north, 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 and eventually you're going south, right? And you're going south, 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 and then eventually going north again, north, 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 north. That's sort of how time would flow at the beginning of Hawking's universe. It sort of flows forwards and backwards, but it never really has a beginning or an end, okay? But to do that, he has to insert imaginary numbers. If you don't remember imaginary numbers are when you take the square root of a negative number. So these are not numbers that we generally use to support scientific theories. So what happens when you put real, what we call real numbers, not imaginary numbers, into Hawking's own equations? You end up with a singularity. You end up with the beginning to the universe. So Hawking's trying to get around this by using this essentially fuzzy math, and he can't do it. Because if you put real numbers back in there, his own equations lead you to the beginning of the universe. So it's essentially an attempt to game the equations to remove the origin of the universe. So those are William Lane Craig's view on the alternatives from a scientific perspective. And so, again, right now, the currently held scientific viewpoint is that the universe had a beginning. And if you've heard that the Big Bang is proof against God's existence, it's because atheists have been trying to steal that ground from Christians and from Jews and from people who believe in God. And so my point is this: the Big Bang is not a way to remove God from the equation. The Big Bang is actually a powerful way to show the possibility of God's existence. And so that's why I feel so strongly about the evidence from physics and astronomy, is because I believe that when we look at the facts as we have them today, that the facts of physics and astronomy lead us not just to an old Earth and an old universe, which I think is true. It also leads us directly to belief in God. And so that's what I wanted to share on physics and astronomy.
Well, that brings this episode to a conclusion. What'd you think? Come on over to restitutio.org and find episode 464, Physics and Astronomy with Will Barlow, and leave your feedback there. On the Restitutio Facebook group, I put out a survey asking people to identify which of the theories that Will had covered in previous episodes they found most compelling. And I was a little surprised by the results. What we found was the majority, this survey's ongoing and it's only been out for a couple of days, so if you haven't yet voted, please come in and vote your view on the Restitutio Facebook group. But the majority, it turns out, are young Earth creationists. And then after that came Walton's temple interpretation, which is the direction in which I personally lean, although I haven't fully made up my mind on the subject either. That was followed by a non-literal interpretation of Genesis with theistic evolution. Will's own theory, which came out in the YouTube exclusive last week, which is the modified gap theory. It's a gap theory that doesn't have a cataclysmic event, so far as I understand it. Correct me if I'm wrong on that. Actually didn't get any support at all. So I don't know if this is just not enough people have voted yet or what. So if you have a horse in the race, so to speak, and you want to sway the community one way or another, please come on to the Facebook group and vote. And as with these other ones, I do intend to do a follow-up episode talking to Will about physics and astronomy and what you just heard here on our YouTube channel. So take a look at that if you're interested. I've gotten a number of comments in over there as well. One by Joseph says, I believe that the word was in verse 2 should be became. Isaiah 45:18 very clearly states that God did not create the heavens and the earth without form and void. It had to become that way. Well, Joseph, I think the majority of folks who interpret Isaiah 45:18 see that as God's intention for creating the world, that he made it to be inhabited, not that he originally started with an inhabited world, but that it was empty to start, and then he created it to be inhabited, that was the intention or telos that he was working towards. Also, as I brought up in the interview with Will in our last conversation, I asked the question, do any translations, any, that he's aware of, translate the verb haya there in verse 2 as became rather than was. And he said no, although he did reference a work by someone who made the case that that is a possibility. But I'm just curious if anyone of you out there who is a gap theorist, which I personally am not, and you think that they should be became, show me a translation. I'd love to see it, and to see that there have been at least some translations that have gone in that direction. I think without any translations going in that direction throughout all of time, you really do have a special pleading here, and you really have to ask yourself the question, well, why is it that nobody else saw this grammatical point in the history of English translation? And I think that's an important point to make. All right, well, that's it for today. We'll catch you next week. If you'd like to support us, you can do that at restitutio.org. And remember, the truth has nothing to fear.